Most AI chips are designed by companies like NVIDIA, AMD, Google, and Apple. These companies decide what the chip should do, how it should be structured, and how it handles AI workloads. They build architectures, optimize performance, and write the software that makes the hardware usable. But these companies do not manufacture the chips themselves. That responsibility belongs to foundries, and this is where control starts to concentrate. The most important company in this part of the chain is TSMC. TSMC produces the majority of the world's advanced chips, especially at smaller process nodes like 5 nanometer and below. Almost every major AI chip company depends on TSMC. If TSMC slows down or faces disruption, the entire AI industry feels the impact. There are other manufacturers, such as Samsung Electronics and Intel, but they currently lag behind TSMC in advanced chip production. This makes TSMC one of the most powerful entities in the entire supply chain. However, even TSMC does not operate independently. To manufacture advanced chips, it depends on highly specialized equipment. The most critical of these machines come from a single company, ASML. ASML builds extreme ultraviolet lithography machines, known as EUV machines. These are used to print incredibly small features onto silicon wafers. Without EUV technology, it is not possible to manufacture the most advanced chips used in AI today. ASML is effectively the only company in the world that produces these machines at scale. Each unit costs hundreds of millions of dollars and requires years to build. This gives ASML a unique position. Even the largest chip manufacturers cannot move forward without access to ASML's technology. The chain does not end there. These machines rely on components and materials supplied by other companies. For example, the light source used in EUV systems depends on technology from companies like Cymer, which is part of ASML, and mirror systems from ZISS. These components must operate with extreme precision. Even small disruptions in this part of the chain can delay entire production lines. Next comes memory. AI systems do not just need processing power. They require large amounts of high-speed memory to function efficiently. This is where companies like SK Hynix, Samsung Electronics, and Micron Technology play a major role. High bandwidth memory, or HBM, is especially important for AI workloads. It allows data to move quickly between memory and the processor. Without enough HBM, even the most powerful AI chip cannot perform at full capacity. This creates another bottleneck in the supply chain. Then there is packaging. Once chips are manufactured, they need to be assembled and packaged in a way that allows them to function as part of a larger system. Advanced packaging technologies, such as chip stacking and interconnects, are becoming more important as chip designs become more complex. Companies like TSMC again play a role here, along with specialized packaging firms. This stage determines how efficiently chips can communicate with each other, which directly affects performance in AI systems. After that comes infrastructure. AI chips are not used in isolation. They are deployed in large data centers operated by companies like Amazon, Microsoft, and Google. These companies provide the computing power that businesses and developers use to run AI models. They are major buyers of AI chips and influence demand at a large scale. Their purchasing decisions can shape which chip designs succeed and which do not. At this point, it becomes clear that control is distributed. Design companies control innovation and software ecosystems. Foundries control manufacturing capacity. Equipment suppliers control the ability to produce advanced chips. Memory companies control data flow performance. Cloud providers control deployment and demand. No single company controls everything, but a few companies dominate each layer. This creates a system where power is shared but also fragile. For example, if ASML cannot deliver enough EUV machines, TSMC cannot expand production. If TSMC cannot produce enough chips, companies like NVIDIA cannot meet demand. If memory supply is limited, AI systems become inefficient. Each layer depends on the others. Geography also plays an important role. Much of the advanced chip manufacturing happens in Taiwan and South Korea. Equipment comes from Europe. Design companies are largely based in the United States. This global distribution creates both strength and risk. It allows specialization, where each region focuses on what it does best, but it also creates vulnerabilities. Political tensions, trade restrictions, or supply disruptions in one region can affect the entire system. Governments are aware of this. The United States has introduced policies to bring more chip manufacturing back domestically. Europe and other regions are making similar efforts. However, rebuilding this ecosystem takes time. It is not just about building factories. It requires skilled workers, supply networks, and years of experience. Another important aspect is software. Hardware alone is not enough. AI chips rely on software frameworks to function effectively. NVIDIA's CUDA platform is a good example. It allows developers to use GPUs efficiently for AI tasks. This creates a strong connection between hardware and software, making it harder for competitors to enter the market. This adds another layer of control. Even if a company can produce a powerful chip, it still needs software support to gain adoption. In simple terms, the AI chip supply chain is a layered system where each layer has a dominant player. Power is not centralized, but it is concentrated within a small group of companies. The reason this matters is because AI is becoming a core part of modern infrastructure. It affects industries from healthcare to finance to transportation. The companies that control the supply chain have influence over how quickly and widely AI can be deployed. Looking ahead, the balance of power may shift, but not quickly. New technologies, new players, and government policies may change parts of the system. But the complexity of the supply chain makes rapid change difficult. Each layer requires deep expertise and long-term investment. For now, the AI chip supply chain is controlled not by one company, but by a network of specialized leaders. Understanding this network is key to understanding where the real power in the AI industry lies.